Hello, my name is Angela Yang, and today I'll be presenting the Math Kangaroo 2018 Level 3 and 4 solution. Problem number 1 says, Lena has 10 rubber stamps. Each stamp has one of the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. She stamps the date of the Math Kangaroo contest. How many of the stamps does she use? So, in simple words, all I have to do is count the number of distinct digits that are up here. So, if we go through, let's just identify all the different numbers that she uses. So we have 0, 3, 1, 5, 2, another 0, but we already counted that as a distinct digit, another 1, but we already have that, and then an 8, which we haven't seen yet. That means she has 6 different distinct digits that she's using to stamp the date of the Math Kangaroo contest. So 1, 2, 3, 4, 5, 6. If you add these all up, you get the answer of letter B, which is 6. Problem number 2 says, the picture shows 3 arrows that are flying and 9 balloons that can't move. When an arrow hits a balloon, the balloon pops and the arrow keeps flying in the same direction. How many balloons will be hit by the flying arrows? So it's evident here that the best way to go here is just to further out the arrows and continue them down the line. So I'm going to be using a box for tally marks for every balloon that we hit. So let's start off with the first arrow. If we just continue off with a straight line ahead, we've already popped 2 balloons. That's 1, 2. Now our second arrow, we keep going. 1, 2, another 2 balloons. And then our third arrow, 1, 2. And that's another 2 balloons. Now if you add up all the tally marks, you get 6 total balloons, which gives you your letter answer of letter E. Problem number 3 states, Susan is 6 years old. Her sister is 1 year younger and her brother is 1 year older. What is the sum of the ages of the 3 siblings? So in order to solve this, we know Susan's age is 6. So we're going to put S for Susan. S equals 6. And we're going to put letter A for her sister and assume her sister's name starts with A and put B for her brother. And using this, we can calculate that since her sister, let's assume her sister's name is Amy or something. If Amy is 1 year younger, then Amy equals to Susan minus 1. And if her brother is 1 year older, then he equals to Susan plus 1. So if we have this, and we want to find some of the ages, we can do Susan plus Susan minus 1 plus Susan's age plus 1, all equals to the sum of their ages, which we'll assume as question mark. So if you look at this, the minus 1 cancels out with a plus 1. So now we're just left with Susan's age plus Susan's age plus Susan's age equals to question mark. So since Susan's age is 6, we just substitute this in and we get 6 plus 6 plus 6 equals question mark. And 6 plus 6 plus 6, if you know addition, which you probably do, is 18, which is our final answer of letter C. Problem number 4 states, the picture shows 5 screws in a block. 4 of the screws are the same length, but one of these screws is shorter than the rest. Which screw is the short one? So the main way to solve this problem would just be to use logical reasoning. So as you can see, these screws seem to progress upward and upward. However, it's evident that 2, 3, and 4 are the highest ones, but 1 and 5 seem to be on the same level. So in order to distinguish this, you use your logic. It shows that 1 extends beyond the block, so it is quite a long nail. However, 5 doesn't, which would mean that 5 is a lot shorter than 1 because although they are the same level, 1 extends beyond the block, but 5 does not. So using logic, since 5 does not have an extending part, we would assume that the 5th screw is the shortest one, leaving us with the answer of letter E. Problem number 5 says, here is Sophie the ladybug. She turns around. Which of the ladybugs below is not Sophie? So to solve this, we need to closely analyze how Sophie's dots are. So for her left, she has 3 dots. And for her right, she has 4 dots. So, if we look at this, we can begin to analyze. She has 3 on her left, 4 on her right. If you look at it from this perspective, 3 on her left, because this is her left, and 4 on her right. From this perspective, 3 on her left and 4 on her right. From this perspective, 4 on her right, 4 on her left, but 3 on her right. So that's not right. But let's double check our answer. 3 on the right, 3 on the left and 4 on the right. So this is correct as well, which leaves us with option D, which is not working. And also another way you can do this is just observe how they have 2 of the same ladybugs in the same position. So you could just analyze these 2 and for similarities or differences, because obviously it's most likely to be one of these, because they're trying to compare which is the right one, which is the wrong one. In this case, letter D is your answer, because the ladybug over here is not Sophie, because instead of having 3 on the left and 4 on the right, they have it switched. There's 4 on the left and 3 on the right, which is not the pattern that Sophie the ladybug has on her wings. Therefore, our answer is letter D. Problem number 6 says, Lucy folds a sheet of paper in half. Then she cuts a piece out of it as shown here. What will she see when she unfolds the paper? So here I have a little demonstration that I created, and we'll look at it at the end. So what I focus on here is actually identifying the shape that's going to be inside here. So this is a very interesting concept, because with a lot of these problems, you have to visualize. So if this is our shape, sorry, my bad art, but if this is our shape, when you open it up, you're basically reflecting it back onto the other side. So our shape would just be this on the other side, right? Which would mean our final result would basically look exactly like this. And that pairs up with the answer of letter D. And some people will really want to know if they're right. So if you wanted to know you're right, you could have made a diagram like I did. So this is the shape that you cut out. So if you think about it and you're reflecting it across, all you're doing is just opening it up and you're reflecting the exact same shape across. So that means you have this shape, which means that once you cut it out, you end up with this shape. And yeah, this proves that the answer is letter D. Problem number 7 says, on her first turn, Diana scores 12 points total with 3 arrows. On her second turn, she scores 15 points. How many points did she score on her third turn? So to solve this, we need to closely analyze the number of points she got for the location of her arrow. So this is the gray area, so we'll name this G, and this is the blue area, so we'll name it B. So when she got 3 arrows in the gray area, we'll say G is the value of, we'll assume G is the number of points you get per arrow that you land in the gray area. 3G equal to 12. Then her second time, she had 2 arrows in the gray area, so 2G plus 1B, so 1B equals to 15. So we can easily do some division here and find out, and if you divide both sides by 3, you find out G equals 4. So that would mean that for every arrow you land in the gray area, you get 4 points. Now that we know G is 4, we can substitute this into this equation. So we have 2 times 4 plus 1B equals 15. That makes 8 plus 1B equals 15. And we subtract 8 from both sides and we get 1B equals to 7. That means you get 7 points because 1B is the same thing as B. So you get 7 points for every arrow you land in the blue area. Now knowing this, we see that there are 3 arrows in the blue area for Diana's last target or arrow round. So that means we just have 3B equals to question mark, which is the value we're trying to find. So if we know B is 7, we just do 3 times 7 equals the question mark. And 3 times 7, as we should all know, is 21. So our answer is that she scores 21 points on her third turn, which gives us letter D is our answer. Problem number 8 says, Mike sets the table for 8 people. He must set the table correctly for each person sitting at the table. Setting the table correctly means that the fork is on the left of the plate and the knife is on the right of the plate. For how many people did Mike set the table correctly? So in order to solve this, we must first acknowledge the perspective of these different people. So I've split the table into different sections. Section 1, 2, 3, and 4. So from section 1's perspective, for every person, the plate is supposed to look like this. If the fork is on the left, it should be like this, and the knife should be on the right. Now from this perspective, we just turn this around and see if it matches, and it does. So that's one person. So we can put like a tally box over here. Now for the second section. For the second section is a lot easier for us because it's already in the exact perspective. So therefore we see that he got this person and this person's setting of the table correctly. So that's 2 more people. Now we look from here. Now if we turn this around, we can see that this does not match this when this is rotated. Therefore, he did not get this person. So he got 2 people over here, 1 person over here, and then 0 people in section 3, and then section 4, which is the hardest. So if you're going to turn this upside down, it's going to look like this. So you're turning the entire picture upside down, which means that the knife will now be on this side and the fork should be on that side. And how many people do you see with this layout set up for them? That's 2 people, this person and this person. So you add 2 more tally marks to your tally box. And that means that he got 2 people in this case. So now your tally box has 5 people, and that's the amount of people that Mike set the table correctly for. That gives you the answer of letter A. Problem number 9 says, Roberto makes designs using tiles like this, with a star and a circle. How many of the 5 designs is it possible to make? So I'm not going to do every one of these because I already have them done out for you. But really the simplest way to do this is just to circle the pairs or draw a line through the 2 pairs. So if you see, you have a star and a circle, right? If you rotate this one way, you get a circle over a star. If you rotate it another way, you get a star over a circle. And if you rotate it the last way, you get a circle and a star. So these are your 4 possible pairs. And if you keep finding these pairings and they end up taking out the entire shape or design that you get, then you have the full design. So when I did this, the first one worked, the second didn't, the third one did work, and then the fourth one did, and then the 5th one did. So only one of them didn't work, and that means that since it's asking for how many of the 5 designs is it possible to make, 4 of the 5 designs work, so your answer is letter D, 4. Problem number 10 says, Albert fills the grid with these 5 figures. A rhino, a shark, a frog, a ghost, and a flower, which I'll refer to as Blossom. Each figure appears exactly once in every column and every row. Which figure must Albert put in the cell with the question mark, which is over here? So basically, if any of you have heard of this, this is similar to a game known as Sudoku. So in order to solve this, we're trying to find the question mark, but there's still some blanks we need to fill in. So every row needs to have at most at least one of each letter. So it must have an S, an R, a G, a B, and an F. So if we look over here, we have G, B, and F. But what letters are we missing? We're missing R and S. So let's write R and S. R and S. Because those are our 2 options for the box. Now let's look over here. We have B, F, and S. So what letters are we missing? We're missing R and G. So now we could put R and G. R and G. Now if we look in these rows, any one of these 4 boxes could be an R. So we need to basically pick wisely. So one of these, in a column there can't be 2 R's, and in a row there can't be 2 R's. So we can only pick one of these as the R and the other one as the S. So let's pick this one as the R and this one as the S. Now if we do this, we automatically have to set this to the R, and this becomes the G. Now if you don't understand why we did this, it's because we can't have 2 R's in one row. So we had to pick one column to have an R. And as a result, you get G, which is ghost. So your answer for what's behind the question mark is letter A, which is the ghost. Problem number 11 states, Tom cuts 2 kinds of shapes out of grid paper as shown to the left. What is the smallest number of shapes that Tom needs in order to exactly cover the boat in the picture? So this boat is pretty ugly, but I think we can still work with it. So here we have Tom and his scissors. So he cuts out a square and a trapezoid. Now, in order to basically solve this problem, you basically just outline all the squares and trapezoids you see in the picture. So for trapezoids, the top has 2 full units and the bottom has 4 full units. So you can use this knowledge to fully identify the trapezoids in the picture. And for the square, it's 2 by 2. So here we already have 1 square, 2 squares, and 3 squares. So that's 3 shapes already. Now we need the trapezoids. So we have one over here, one over here, and one over here. And through this, you can see that the trapezoids can also be upside down. They don't have to be always upright. They can also be upside down. And that's 3 trapezoids. So that's 1, 2, 3. And now if we look at our tally marks, we have a total of 6 shapes. So therefore, our answer is letter B, 6. Problem number 12 says, the colors in this picture are switched. Then the picture is rotated. What does the picture look like now? So I didn't draw all 5 choices because it doesn't quite matter about the placement of the dots. Well, if you see in letter A, if you look at letter A, you'll see that the big dot, the one with the black in the middle, is not in the right placement. And also, there are a total of 1, 2, 3, 4, 5, 6, 7 dots in total. And the first option, letter A, has 1, 2, 3, 4, 5, 6, 7, 8 dots. So letter A is off the list. Now we have letter B. Now letter B obviously only has 5 dots and doesn't even have the large dot over here. So that's already out. Then we have letter C. Letter C seems to have the right placement so far. And if you count, there are 1, 2, 3, 4, 7 dots. However, if you look closely, the large dot with the color in the middle is way closer to the other dots compared to the actual picture. So it can't be letter C. And then letter D only has 5 dots, so that's not possible either. And then there's letter E, which perfectly matches with 7 dots and has the right placement of the large dot. Now in this case, focusing on the placement of the large dot definitely does help you get the answer. And in this case, the answer is mostly achieved through visual observation. And through your observation, you should perceive that the answer is letter E. Problem number 13 says, Peter Rabbit has 20 carrots. She eats 2 carrots every day. She ate the 12th carrot on Wednesday. On which day did she start eating the carrots? So in order to solve this, I would recommend drawing a table with each of the days labeled. So on Wednesday, Peter Rabbit ate her 11th and her 12th carrot. On Tuesday, she ate her 9th and her 10th. On Monday, she ate her 7th and her 8th. On Sunday, she ate her 5th and her 6th. On Saturday, she ate her 3rd and her 4th. And on Friday, she ate her 1st and her 2nd. So Friday is the first day that she started eating. And I would recommend this charting method because it's a lot more efficient and less likely to produce an error. So now that you know your answer is Friday, you can get the answer of letter E. Problem number 14 says, Toby glues 10 cubes together to make the structure shown to the right. He paints the whole structure, even the bottom. How many cubes are painted on exactly 4 of their faces? So if you think about it, a cube has 6 sides. So if 4 of the sides must be painted, then that means 2 sides must be covered. So 2 of the sides of the cube must be touching the parts of another cube. Therefore, if you evaluate this, you can eliminate certain cubes. So let's start off with the top cube. So if we look at this top cube, only one of its surfaces is touching another cube. Therefore, this has 5 surfaces painted, which doesn't match the requirements, so that can't be it. Then we look at the next cube. The next cube is touching both the top and the bottom of another cube, which means that it's eligible. So that's 1 cube so far. The cube below it matches the same requirements. It's touching the surface of the cube above and the surface of the cube below. So that's 2 cubes. Now we have this one where it gets a little tricky. So it is touching the surface of the cube above. So we're talking about this cube over here. It is touching the surface of the cube above, and it's also touching the side of another cube. so therefore it also counts. The same method applies for this cube and this cube and this cube. And for this cube, the same concept over here. So that's another 3. So 1, 2, 3. And then over here we have a back cube, and its surface is touching the cube in front of it and the cube behind it. So that's another one. And then over here we have the same situation as we had over here, where only one of its surfaces is touching another cube. So that can't be it. But the cube below it matches the requirements, so that's another cube. And now that you tally up all those marks, you get a total of 8 cubes, which is your answer of letter C. Problem number 15 says, there are 8 flowers on a rose bush. Some butterflies and some dragonflies are sitting on the flowers. There is no more than 1 insect on each flower. More than half of the flowers have an insect on them. The number of butterflies on the flowers is twice the number of dragonflies on the flowers. How many butterflies are sitting on the flowers? So in order to solve this, you need an equation. So if the number of butterflies is twice the number of dragonflies, then we have D as dragonflies and B as butterflies. That means that 2D equals to B. So the number of butterflies is twice the number of dragonflies. So 2 times the number of dragonflies equals the number of butterflies. Now that would mean that if this is the case, if we're getting the total number, let's assume that the total number is x. So x would equal to 2d if we substitute in b, because x is supposed to equal to b plus d. But since b is also 2d, we put that in, plus d. So 3d has to equal to x. That means that x must be a number divisible by 3. And it also must be over half of the number of flowers. Since there are 8 flowers, x must be over 4. So x must be greater than 4 and also a multiple of 3. And what number do we know that does that? The number 6. So assuming that x is the number 6, we do 3d equals 6. And d ends up equaling 2. So that means the number of dragonflies is 2, but we're finding the number of butterflies. And since the number of butterflies is twice the number of dragonflies, you just do the number of dragonflies times 2, which equals the number of butterflies. So that means it's 2 times 2, so the number of butterflies, there are 4 butterflies. That gives us the answer of letter C. Problem number 16 says, Captain Cook wants to sail from the island called Easter through every island on the map and back to Easter. The total journey is 100 kilometers long. The direct distance between desert and lake is the same as the distance between Easter and Flower via volcano. How far is it directly from Easter to lake? So in this case, I've represented each of the islands with a letter, which corresponds to the first letter of their title. So if we know this, that the entire trip is 100 kilometers long, we should know that by adding together each of these segments, we should get a total of 100 kilometers. So first we have segment EV plus VF plus FD plus DL plus EL should equal 100 kilometers. So we know that the distance between D to L is the same as the distance between E to F. So E to F should be same as D to L. D to L is 26, and we want to find V to F. Or we just substitute out EF, because EV plus VF is just EF. So that's 26. Now we need to know FD, which is 15. DL is 26. And then EL is basically what we're trying to find, the distance between E to L. So this is what we don't know. And all this equals to 100 kilometers. So if you substitute it in, you have 26 plus 15 plus 26 plus EL, which we can refer to as X because it's an unknown value, equals to 100 kilometers. Now if you do the math, 26 plus 26 is 52. Plus 15, which is 67, plus x equals 100. Now you just subtract 67 from both sides, and x equals to 33. So your distance from E to L, from Easter Island to Lake Island, is 33 kilometers, which gives you your answer of letter D. Problem number 17 says, the rooms in Kanga's house are numbered. Baby Roo enters the main door, passes through some rooms, and leaves the house. The numbers on the rooms that he visits are always increasing. Through which door does he leave the house? So in order to solve this, you just trace your path through. So basically what you would do is just continually go through the higher numbers. So if you look at it, there are many different paths that you could easily go through. So, but this kind of problem takes a lot of testing. If you start off from 1, you go to 2, and you can go to 4, 6, and then 9, 12, but then you're stuck at 9. So you can't go to 2. So if you try 3, you want to 3. So you have to go to 5. And then next up, the next highest number would be 6. You could go down to 6. Then you can go to 7. You can go in direct order. Then to 8. Then to 9. And to 10. And then you end up at door D, which gives you your answer of letter D. Problem number 18 says 4 balls each weigh 10 grams, 20 grams, 30 grams, and 40 grams. Which ball weighs 30 grams? So in order to solve this, you need to examine how the scales are positioned. So in this case, A plus B, the weight of A plus B is a lot greater than the weight of C plus D. And in this case, the weight of B plus D is exactly equal to the weight of C. So if we do this, we could do some assumption and calculation. So if you substitute in B plus D, you have A plus B is greater than B plus 2D because it equals to C. They have the same weight. And now that you have that, you know that A, the weight of A, is greater than 2 times D. So that means that the weight of A must be 40, and then D has to be 10. Because there's no other way to have this, there's no other real way to have this to be true, because D can't be 20, because then it's equal to 40. So now we already have A, which is 40, and we have D, which is 10. So if A is 40 and D is 10, now we have the rest of our equations. So we know that D is 10, so we have 10 over here. Now our only values left are 20 and 30, and that's for B and C. So B can't be 30 because 30 plus 10 isn't equal to 20. B must be 20 because 20 plus 10 is equal to 30. Therefore, B is 20 and C is 30. And since we're trying to find out which ball weighs 30 grams, that's ball C, which gives us our answer of letter C. Problem number 19 says, the band shown in the drawing can be fastened in 5 ways. How much longer is the band fastened in one hole than the band fastened in all 5 holes? So as you can see, basically the way the band works is that these are the hooks that hook into the holes. So assuming that we have, this is when the hook is on the first hole. So, and then when it's on all 5 holes, all 5 of the holes would be filled. So that means that we're figuring out the distance from this point to basically this point. And since we already know that the distance between like 2 points is 2 centimeters, and this applies for both, we can just do, basically, we have our 5 dots, and we find 2, 4, 6, 8. And that's 8 centimeters distance between the points. And therefore our answer is letter B. Problem number 20 says, in an ancient language of symbols, an eye, a sun, I'm going to refer to this as a star, and then stripes, and then a fish, represent the following numbers: 1, 2, 3, 4, and 5. Nobody knows which symbol represents which number. We know that 2 stars, a star plus a star equals a fish, a sun plus a sun equals a star, and then a sun plus a fish equals to these stripes, which I'll just refer to as a shell. So this kind of problem requires a lot of logic and substitution. So if we know that 2 suns are equal to a star, then we can substitute this in. If 2 suns equal to a star, then 4 suns equal to a fish. And if 4 suns equal to a fish, we substitute that in over here with the fish, and then we have that 5 suns equal to a shell thing. And now that we know that, we know That's the sun. The number of the sun must be the value of 1, because 5 times whatever the sun is has to equal to the shell, the value of the shell, and we know that the maximum value is 5. So that means 5 divided by 5 is 1. So we know that the sun is equal to 1. Now that we know that, since 5 suns equal to 1 shell, 5 times 1 equals to 5, and so this shell thingy is equal to 5. Now we need to know what 2, 3, and 4 are. So we know that a sun is 1. So 1 plus 1 equals to 2. So the star is 2. Now we need to know what 3 and 4 are. So we know what the star is. The star is 2. 2 plus 2 equals to 4. So our fish is 4. And the one value that hasn't been designated on this board yet is the I. And the only value left is 3. Therefore, the I equals 3. And that gives us our answer of letter A. Problem number 21 says, the hexagonal stained glass tile is flipped. One of the flips is shown. What does the stained glass tile look like at the far right? So this is one of our flips. And the main key to this problem is logically figuring out how you're going to flip it across. So instead of drawing the animals, because I have no artistic talent, I have chosen to do letters in substitution. So there's an ant, a dolphin, a cat, a ladybug, and then a dog, which I'll just replace with a P for puppy, and then a butterfly. So now that we have that, let's begin to figure it out. So we know that if we reflect this directly across, D has to be here, C is going to be here, A flips across, then P is directly flipped over here, and then B, P, and then that's a B, and then L. And now we flip it across from here. Now we have a B, A, P, P, and then we flip it across over all the way across, C, D, and then an L. So this is our final layout. Now all you have to do is compare this with one of the answers. And if you look, letter B has an ant over here, a butterfly over here, a puppy over here, and then a ladybug over here, a cat over here, and a dolphin over here. Therefore, letter B would be our answer. Problem number 22 says, the large rectangle is made up of a number of squares of various sizes. The 3 small squares each have an area of 1. What is the area of the large rectangle? So in order to do this, we need to basically substitute in some side values. So everyone should know by now that in a square, each side is equal. So if you figure out one side, you have the length of all the sides. So here we have 1 by 1, 1, 1, and 1. So that means that the sides of this square are 1. So that means the sides of this square are 3, because 1 plus 1 plus 1 is 3. And the side of this square as well is also 3. So that means this square's area is 9. Now that we know that, if we figured out one side of this square that has a side length of 3, we have 3 over here as well. And then also a 1 over here. So 3 plus 1 is 4. And then 4 is also on that side. So 4 times 4 is 16. Now we have 3 and 4. So 3 plus 4 is 7. And 7 times 7 is 49. And now we have finally 7 and 4. And 7 and 7 plus 4 equals to 11. And 11 by 11 is 121. So now all you do is add together these numbers. You add 121, 49, 16, 9, and then these 3 ones over here. So if you do that, you get plus 9, 130, 170, plus 16 plus 9, which is 25. So that's 195. And then plus this 3 over here, we get to 198. And that's our final answer, which gives us the answer of letter D. Problem number 23 says, Leon wants to write the numbers from 1 to 7 in the grid shown. 2 consecutive numbers cannot be written in 2 neighboring cells. Neighboring cells are those that meet at the edge or at a corner. What numbers can he write in the cell marked with the question mark? So most kids would try and actually solve out each individual cell, but to be honest, all you need to solve this problem is logic. So we see that the question mark cell is over here, and let's mark all the cells that touch it. So these 3 cells touch it through the edge, and these 2 touch it through the corner. Now we need a number that isn't consecutive to 5 other numbers, and the only numbers that suit this are 1 and 7. Now if you're confused, let me explain why. If the number is 1, you still can't do 2, but you still have 3, 4, 5, 6, and 7, and that's 5 other numbers. If you do 7, you can't do 6 because that's consecutive to it, but you can still do 5, 4, 3, 2, and 1. Now you may be thinking, well, what about 2, 3, or 4? What's wrong with those kinds of numbers? Well, let's see. If you do 2, you can't do 1 or 3, so that only leaves you with 4, 5, 6, and 7, and that's only 4 numbers. And this the number in the question mark box must not be consecutive to 5 numbers, and that's only 4. And this same thing over here applies to the numbers 3, 4, 5, and 6 as well, which means that our only possibilities would be 1 and 2. And if we examine our answer options, that gives us the answer of letter E. Problem number 24 says, to defeat a dragon, Matthias has to cut off all the dragon's heads. If he can cut off 3 of the dragon's heads, 1 new head immediately grows. Matthias defeats the dragon by cutting off 13 heads in total. How many heads did the dragon have at the beginning? So in order to solve this problem, you need to work backwards. So our 2 end scenarios are either that the dragon has 2 heads and Matthias cuts them off, or it has 1 head and Matthias cuts them off. So let's start off with the 2 heads. If the dragon has 2 heads in the end, that means before this he either had 4 heads, because then these 3 would have amounted to 1 and this extra would have been that one, or he had 6 heads. But if he had 4 or 6 heads, that means the next time he would have had to have either 12 or 18 heads, and you're adding 12 or 18. And first of all, these numbers will be far too large, and second of all, our number is odd. And we're basically adding an even number to an even number to an even number. And we can't have an even number in the end. Our number is odd because it's 13. So that erases the possibility of having 2 in the end. So now we're left with having 1 in the end. So if we have 1 head in the end, that means that before that 1 head, Matthias must have cut off 3 heads. And before those 3 heads, Matthias must have cut off 9 heads. Now if we look closely, Matthias had to cut off this head and then all these heads as well. And if you count how many there are, there's 9 plus 3 plus 1. And that equals to 13. So that means Matthias cut off 13 heads. And that matches the requirement set from the problem. Which means that in the beginning, the dragon that he was trying to defeat had 9 heads. Which gives you the answer of letter B.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!